Hello everyone, this is Mrs. Villar's first Algebra 2 video note. Before we start our notes, I wanted to just remind everybody to get your Algebra 2 student expectations signed and bring that back to me tomorrow. Make sure you read through that real well. It has your supplies and your expectations and has the technology survey and everything in there. Remember that that will be a test grade and I need those back by Friday, but bring those back as soon as you can. So, let's go ahead and move on to the notes. All right. Tomorrow in class, we're going to be discussing relations and functions. So, we're going to start off with relations. A relation is just simply a relationship between a set of ordered pairs. And you're used to seeing different representations of those. These are some of the common ones from Algebra 1. Just having a list of ordered pairs. Remember that your ordered pairs are always ordered. They're always in XY order. Luckily, that's alphabetical order. So that's easy to remember. They also may have your relation be a graph. Here we have ordered pairs graphed on a Cartesian plane here. Now remember with your ordered pairs that they always go left or right first, and then they'll go up and down. Okay? So this point here, 0, -2, actually is in this grid also, because to graph that point, I would go 0 left or right, and then I would go down 2 right there. And so that's the same point as the first ordered pair here. Now, on the mapping, you saw these a little bit in the past. You probably haven't done a whole lot of them, but you're familiar with them. Remember that your x values are always on the left, and your y values are always on the right. And that shows the ordered pairs x to y. So we have a ordered pair 0, -2 here, 0, 2, 3, -1, 3, 1, and 4, 0. Now, we also have a table, which y'all are very familiar with from last couple of years, and those are also always in order, x, y. We also did a lot of linear equations in Algebra 1. Now, so here we have the equation y equals 4 minus x, where x equals 0, 3, and 4. Well, notice this 0, 3, and 4 are the same numbers up here that we had for x in the mapping. Now, but there is a problem here. For some reason, there's something wrong with this equation that doesn't allow it to look like this graph up here. So I want you to think about that, and tomorrow we'll discuss that in class. Hopefully someone will have the right answer why this does not produce this. Okay, now, two terms you need to be familiar with when you're talking about functions and relations. So far we've just talked about relations. We'll get to functions in a minute. But domain and range. If you remember that domain is the set of x values, the input values. And your domain is always your independent variable. It comes first in your ordered pair. The range of a relation is a set of output values, the y values. Your y is your dependent quantity. The dependent quantity is always the second value. So, down here we're going to find the domain and range of these functions. We're not going to do e because we're still not sure what's wrong with that. And we'll talk about that tomorrow. But we're going to look at the rest of them, because if you'll notice, they are actually all the same function. We got 0, -2, 0, 2 is up here. We have 3, -1, 3, 1, and 4, 0. And you end up with the same points all here also. And of course, all the points are listed in the XY chart. So we can find the domain and range for all 4 of those representations at once, because they have all the same domain and range, because they are all the same relation. So when you write domain, we're only going to look at the x values, only the very first values. And actually, let me move this down a little bit, because I've got my x, y over. See, does that work? Move it down a little bit more. So, no. Sorry guys, I'm still learning how everything works a little bit. So, think you can see everything there. So anyhow, I'll just rewrite this. Nope. Try again. So this is going to be 0, -2. I'm just going to write that back in. Now, when we find domain, there's a special way that you have to write it. You're going to put an open bracket. You may or may not have done this in the past, but this is the expectation. Everybody's going to take it at the start, at the end of the year, or the tax, and this is the correct notation. So, for domain, you're going to start with an x, since domain is always your x values. Then you're going to put a bar that goes up and down like that, just a vertical bar. And then you're going to put x equals. I know it seems redundant, but that's the way it's supposed to look. And so, what we're going to do is we're going to list all of our x values, because we just want to look at the domain. So we're going to go back and just look at the x's themselves, all of these x's. And we want to list them in numerical order. So luckily for this, they already are in numerical order. We have a 0, a 0, a 3, a 3, and a 4. Now, the thing is, though, when you do domain, you're only going to write the number once. If it appears more than once, don't worry about it. You just go on to the next one. So we're going to put 0. We're not going to worry about this one right here because we already have a 0. We're going to put this 3. Skip the next 3 because we already have it, and then a 4, comma, 4 at the end. And then, of course, we're going to put our bracket at the end. For every open bracket, you're going to have a closed bracket. Now, for our range, we're going to do the same thing, except this time, we're going to put an open bracket, except for this time, we're going to do our y values. Now, our y values are always the second value, so I'm only going to look at the second values. So I'm going to do all of these second ones. However you do it to differentiate between the two, that's fine. But I'm going to put y, I'm going to put a big bar, just like I did over here. And then I'm going to put y equals this time. And y equals, are these in numerical order? -2, 2, -1, 1, 0. No, they're not. So I need to do a little thinking here. So all those values, the smallest one's -2, comma, and then the next one would be -1, then 0, then 1, then 2. And then again, for every open bracket, there's a closed bracket. Sorry about that, ran out of a little bit of room. So I'm going to pause there. Okay, moving on to functions real quick. A function is a relation in which each x value corresponds to exactly one y value. No x coordinates are used more than once. In other words, no x's are repeated. If you have a repeating x in your relation, then you do not have a function. So add that. Whoop, oh, again, still learning. Okay, let's try again. So right here, does not repeat. Well, and let's put x does not repeat. Okay, so determine whether each of the following relations is a function. So on this first one, I don't care what the y's are doing, I'm only going to look at the x's. So I'm going to underline all these x's so I can focus in on those. If I have any repeating values, then as soon as I have one repeat, I'm done. Not a function. So I have 0, 0. So I don't even have to look at the rest of it. Definitely not a function. And plus these 3's here mess it up too. So pause it for a second and I want you to work on problem 3. Figure out what you think it is. On number 4, remember that these mappings, this is your x and this is your y. So think about if this is a function, yes or no. And then of course look through your ordered pairs real quick and decide if those are functions, yes or no. All right. You should have gotten yes on this one. Oh, sorry, still learning the pen. And this one. Now here we have 2 arrows coming off of this one. So that means we have a point at 1, 3 and 1, 4. So there would be 2 1s for the x's. So this was definitely no. So watch for that. If you got more than 1 arrow coming off your x, definitely not a function. And then over here, if I look at all my x's, they're the same. So I'm good to go there. All right. If a graph of relation is given, the vertical line test will determine whether or not the relation is a function. A relation is a function if no vertical line intersects its graph more than once. So underline vertical line here, because that's what you're going to do to your graph to determine if it is a function or not. What that means is if you draw a vertical line, remember vertical's up and down, if you draw a vertical line anywhere on that graph, it should only touch it one time. So once, 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 once. If it only touches it one time anywhere on that graph, then you're okay. Yes, you have a function. Okay? Now, if we have a graph like this, and I draw this through, definitely hitting the graph more than once. I'm hitting it up here and down here. So that means I have two x values that are the same. This point over here is negative, looks like to me -3, 6 or so, and this one down here is -3, -6 or so. So you have two values of -3, so definitely not a function. And then over here, again, even though it's ordered pairs, you're still going to draw a vertical line through there. And as soon as I draw a vertical line right there, I'm hitting it twice, so definitely not a function. Okay, we're going to pause there. Okay, almost done here, guys. This should be pretty easy for us to do here because all we're going to do here is substitute a little bit. Now, what we see here is function notation. Oh, I got to get back to my pen. What we see here is function notation. F of x. All that is just fancy symbols for that it's a function. And we'll talk more about that in class. But remember that f of x is the same thing as y. So this could also be written as y equals 5x minus 1. Now what we're going to do here is they're going to ask us to find the value of the function when x equals 10. So all we're going to do, if we're solving for f of 10, oops, I messed up. Let me erase that. First time I get to use my eraser. Isn't that cool? Awesome. Okay, so let me go back. So I've got f of x. No, I did it again. One more time. Okay. Pen. All right, so we're going to find f of 10. Now what that means is we're just simply, instead of using an x, we're going to put in a 10 wherever there is an x. So we're going to do 5 times 10 minus 1. So 5 times 10 is 50, minus 1 is 49. So f of 10 is equal to 49. Easier than it looked originally, isn't it? And really all that means is that if you were to graph this, if you went over 10 for your x, you'd have to go all the way up to 49 to be able to graph the point that goes with that. So basically what it means is that you have a point at 1049 on the graph y equals 5x minus 1. All right, let's do the same thing over here, but this time we actually have a quadratic, and we're going to talk more about that at the end of this week too. So this one, they give us a different function, f of x equals 2 plus x squared, and we want to find the value of the function when x equals -3. So we're going to do f of -3 equals, and I'm just simply going to put in a -3 where I have a squared. Now, the problem is here is you need to be careful. We want to square this negative, so we're going to put parentheses around it, because if you don't, you're going to have a problem when you put it into your calculator if you like to use the calculator. So this is going to be f -3 equals 2 plus, of course, -3 squared. -3 times -3 is 9 equals 11. So our answer is 11. When x is -3, the function is equal to 11. This 11 is our answer, but just so you understand again, that means you'd have a point at -3, 11 on the graph. Okay? All right. I hope you understood everything. Remember, you can always go back and rewind. Remember, I also put an extra help PowerPoint on my website. So you can go to the website and find that PowerPoint in there. It's labeled Extra Help, Functions and Relations. And we'll talk more in class tomorrow. Get some rest.